Okay, so to continue on here, now that we've sketched the curves, again, when you were to sketch those, you were to pay attention to the factors, and x plus 4 would give a 0 at x equals negative 4, x plus 3 would give a 0 at x equals negative 3, and x plus 1 would give a 0 at x equals negative 1. Positive lead coefficient means in general the graph is increasing from left to right. And also notice that when the distance between zeros is greater, the curve goes down further or up further from the x-axis. So when the zeros are closer together, it doesn't go up as high. When they're further apart, it goes down, in this case, lower. Also, because it's degree 3, the ends go in opposite directions. Okay, you can actually see that the distance between the zeros has a profound effect on how far the graph does go, because the graph should just be a smooth curve, basically symmetric between each of the zeros. There shouldn't be any kind of little wows in there anywhere, so it should just be a nice smooth curve going from one zero to the next. Lead coefficient is negative, so in general the trend is decreasing from left to right. The three factors would give zeros at x equals negative 4, x equals positive 2, and x equals positive 5. And it is degree 3, so the ends go in opposite directions again. Moving along to these quartics. Positive lead coefficient, so it's going to be opening up generally. We've got the four factors which would give us the four zeros. And degree 4, so the ends go in the same direction. For this one, opening down because it's negative, lead coefficient is negative, so generally it's opening down, and these four factors are going to give the four zeros here. And of course, again, the ends go in the same direction. Okay, same kind of idea. Now we're just going to be looking at different types of cubics and quartics. So again, we've got 1 power of x here, and then here's another 2, so that means that the degree is 3. Lead coefficient is positive. So the general trend of the graph from left to right is increasing. We have a 0 at the origin, x equals 0, and we have another 0 at x equals 3. In this case we have 2 turning points. And we see that the ends are going in the opposite directions of each other. And I guess that's about all we're looking at for now. Okay, moving along to part B. We've got degree 2 here and degree 1, so when you multiply those together you're going to get degree 3. We've got a negative lead coefficient, which means that generally speaking the graph is decreasing as you go from left to right. We have zeros at x equals negative 1 and x equals 2. And we've got 2 turning points. For C, positive lead coefficient, which means generally from left to right the graph is increasing. It is degree, there's 2 and there's one more here, so there's degree 3. There are 2 turning points. And we've got a 0 at x equals 0 and a 0 at x equals 3. And for part D, again, degree of 3. Lead coefficient is negative, generally decreasing from left to right, and these zeros are x equals negative 2 and x equals 0, and the ends go in opposite directions. And 1, 2 turning points. Okay, now just a few things to take a look at here. Notice that whatever would make y 0, so in this case x is 0 here, that's a 0, x is 0, that x has a degree of 1. Notice that the 0 that goes along with that factor cuts right through the x-axis. That's called a linear root because it's degree 1, and the graph just cuts straight through like a line through the x-axis. So that's called a linear root. Where we have a degree 2 at x equals 3, that factor has degree 2. That's called a quadratic root, or a double root, where that could be written as x minus 3 times x minus 3, but that just gives the same root at x equals 3, or the same 0. So this is called either a double root or a quadratic root, because it kind of resembles a parabola right here, where it just kind of bounces off the x-axis. Okay. Again, 2 turning points for the degree of 3. Same kind of thing here. We've got a quadratic root at x equals negative 1 because it just bounces off the x-axis. And we have a linear root at x equals 2 because the degree here is just 1. Okay, so the line, that part of the graph just looks like a line just cuts through the x-axis, so that's called a linear root. And again, 1, 2 turning points with degree 3. Okay, sketch these 3 curves please and come back for the big reveal.